Hello, everybody. In this problem, we are going to be computing the Fourier series of a two-periodic function. So it's not quite the 2 pi periodic function that we love, but it's pretty close. Two isn't so bad. So in order to compute the Fourier series of this two-periodic function, right, which is defined between -1 and 1, we're going to be using our Fourier series formula, which in this particular case, right, so our Fourier series for f is going to be given by a naught over 2 plus, okay, we're going to have a sum starting from 1, and then we'll have a sub n cosine of, well, let's see here. It's usually going to be n pi t over L, where L is the half period. Well, in this case, we have a two periodic function, so our L is just equal to 1. So it's just going to be n pi t. All right, that's not the worst thing in the world. And then we also have our sine term, so bn sine of n pi t. All right, well, that's the Fourier series, but we, of course, the devil is in computing these coefficients. So the formula for the coefficients, okay, so a sub n is going to be 1 over the half period. Well, that's just 1. And then we're going to integrate over the domain of definition. So we're going to go from -1 to 1. Fine. Then we have our function. Well, let me just write f of t in here for now. Cosine of n pi t dt. And then, of course, we also have the same thing for our b sub n, only we replace the cosine with a sine. So this is really our job in this problem, is to compute these integrals. Now, what can we say here? Well, the function is piecewise, so we're going to have to break these integrals up. So I'm going to integrate from -1 to 0. And when I go from -1 to 0, I get a -1 for my value for f. So this is actually just negative cosine of n pi t. Then I'll integrate from 0 to 1. And now on that interval, the f is just 1. So I just get cosine of n pi t. Well, this is not too shabby. One thing, by the way, I'll just point out, a lot of people make mistakes at this, actually the previous step here. When they go to integrate, they just say first, I don't know why, but in their brains, they start thinking, oh, right, I'll do the cosine from -1 to 0 and the sine from 0 to 1, or something like that. It doesn't make any sense, but a lot of people do it. So don't do that, right? Like, you just have to do this literally, right? You can't shortcut this. All right. And of course, we can write down the same thing for the sine. All right. Everything is going to copy over pretty nicely. Okay. So, can we find any tricks to simplify our calculations, or do we just go jump right in and do this straightforward? Honestly, there probably are some nice symmetry tricks we can do here, but in the test, man, maybe we don't waste our time thinking about how to do it, and we can work on those later. All right, so let's see here. I'm going to start by looking at just when n is at least 1. Good idea to do that with your a's, because you're usually going to be dividing by an n somewhere, and of course we don't want to divide by 0. So when I find an antiderivative for cosine, that's going to be sine. Of course, there's this negative that floats around. So I have negative sine of n pi t. But again, I'm anti-differentiating with respect to t. This n pi is a constant. I'm going to have to divide by it. So I divide by my n pi, and then I'm going to evaluate between -1 and 0. And I do the same thing in the second piece, only now I don't have to worry about a minus sign. Oops. Yeah, so we have plus. Now we have sine n pi t over n pi, and I evaluate from now 0 to 1. Okay, again, you can see I don't want to be dividing by 0, so I'm going to have to handle the a0 case separately. All right, well, when t is equal to 0, the sign is nothing. So nothing to do there. When t is -1, I get sine of negative n pi. Okay, but n is some sort of integer, and I multiply it by pi. That means I'm living on the x-axis, where the sign is always 0 anyway. So in fact, this is just going to be 0 minus plus doesn't matter, 0. And for the exact same reasons over here, right? I put in a 1, I get an n pi. Sine of n pi is always 0. If I put in a 0, sine of 0 is still 0. So this whole thing is going to be 0. All right, so my a sub n is equal to 0 when n is at least 1. What about the n equals 0 case? So now I would have a sub naught is equal. We're going to integrate from negative 1 to 1. And the function now, right, we have cosine of 0, which is 1. So I just get the function f of t. Okay, well, again, maybe I'll break this up just to make it really transparent. So I have a negative 1 on the first component, and I have a positive 1, right, on the second component. And it's really easy to integrate these, okay? I get here negative 1 times the length of the interval, which is 1. So I get negative 1. And here I get positive 1 times the length of the interval, which is 1. Hey, these still add to 0. So all of the a's are 0. I don't get any of the cosine coefficients. Fine, let's move down to the sine coefficients. So we'll do the b's. So b, remember this was going to be integrating from negative 1 to 0, negative, now it's sine of n pi t. And then we'll integrate from 0 to 1, and then we get a positive sine of n pi t. All right, so when I integrate sine, I get negative cosine. But here's another negative. So I have a positive cosine n pi t. Of course, we have to divide by n pi. And then we integrate from negative 1 to 0. We evaluate between negative 1 and 0. And then we get the same thing over here, only now we do actually pick up a minus sign. So we'll have minus, and then we have cosine n pi t over n pi evaluated between negative 1 and 0. Okay, let's see. At 0, I get cosine of 0, which is 1, divided by n pi, right? Okay, so 1 over n pi. That's fine. Minus, now what happens when t is negative 1? Well, actually, I don't care whether it's negative 1 or positive 1, because the cosine is an even function. So I might as well just look at n pi. And cosine of n pi is just an alternator. This is minus 1 to the n. Over n pi, of course, still. Okay, let's jump over to the other one. We have minus. Now again, we wrote negative 1 to the 0. Of course, this is supposed to be 0 to 1. At 1, okay, there's our alternator, minus 1 to the n divided by n pi. Minus, and at 0, we get, again, 1 over n pi. Okay, oh my goodness, does everything cancel out? Oh, not quite, I would guess. So let's see. I have a negative, this alternator, minus this same alternator. So there's going to be 2 of those. But then let's see, 1 over n pi minus, minus, okay, it's a plus. So we're going to have 2 copies of both of these. So we're going to have 2 copies. I have an n pi that I can factor out. And what's left over? I have 1 plus, or minus rather, I should do minus, negative 1 to the n. Okay, well, can we simplify this bit? Yeah, I bet we can. So let's see, we have 2 over n pi, and then when n is odd, what happens? When n is odd, I get negative 1 to an odd power, which is negative 1. 1 minus negative 1 is 2. So I get a 2 in that case. When n is even, now this becomes negative 1 to an even power, which is 1. 1 minus 1 is 0. So I get a 0. And so in total, I have 2 cases. In the first case where n is odd, I have 4 over n pi. So that's where n is odd. And in the second case where n is even, I get a 0. Therefore, my Fourier series is, okay, remember we had no cosine terms, and we're only going to get sine coefficients in the odd places. So I can write n odd, and then I'll have 4 over n pi sine of n pi t. Or if you liked, you could pull this 4 over pi out. 4 over pi, and then the sum over n odd, 1 over n sine of n pi t. Either way. All right, let's go back up and see what the problem told us. Hey, look at that. 4 over pi, the sum over n odd, sine of n pi t over n. That's what we got at the end of this. Whew, we did it, everybody.